Hi, and welcome to College Algebra 3.5. Today we're going to talk about mathematical modeling again, as well as variation. So, quick refresher on mathematical modeling. If I'm given some data that's not necessarily linear, as you see, there's all these red dots along there, including this green dot. Make it red. You can tell that there's not a natural line for it. So there's a couple ways we can model this data, if we remember. The first one is pick the first two coordinates, these two red coordinates here, and create this green line by just doing, slope-intercept form after doing slope form and point slope form and creating a line. That being said, the green line doesn't look necessarily representative of my data. So what we also did is a regression in our calculator. So taking out our calculator, we can go to Stat, 1 for edit. And what we can do is put all the x values in the L1. So I'm going to put all these in my L1. I'm going to put all of these in my L2, which I did. I can then go into Stat, over to Calc, and I can choose what kind of way I want to represent this data. For now, we're just going to stick with a linear regression, or a line of best fit. If you wanted to, you can do store rec EQ and have Y1 in there. I believe that's alpha, trace, enter. And it's actually going to find my equation and put it in for Y1. And hit calculate, and it gives me the equation right here. And again, it'll be in the Y equals, as you see. If you wanted to see it, you hit the trainer stat plot on. You would then go to zoom 9 for zoom stat, and you can see it actually physically draw the line in the coordinates with the type shape. See, that's roughly what I have there in black. I missed it a little bit when I did it. Okay. Now, the question goes on to say, what can we predict for 2024? As we can see, that would be year 6, where 2025 would be year 7. So all I can do is just plug in 6 or 7 into my equation there. The nice thing is I can actually also do zoom out, and I can just go second calc value and plug in 6 directly and get about 12.55, or second calc value 7 and get about 13.2, which is all I kind of did there. 12.56 is when you plug in 6 based on some estimation. This process is called extrapolation. You're taking data and trying to predict future things. Okay, that should be review. We talked about that probably a week and a half, 2 weeks ago. Next, variation. We have direct variation. One goes up as the other one goes up. So that can be modeled, like let's say I had an equation like this. As my x goes up, my y is going up. As my x goes down, my y is going down. Well, that's just linear in nature. So by definition, direct variation is y equals k x, where k is just some number. Okay. Inverse variation, one goes up as the other goes down. Well, graphically, as x goes up, the y value has to go down. And as x goes down, the y value has to go up. This should look very similar as well. That is just part of the reciprocal function. So it looks very reciprocal in nature. Joint variation means there's multiple variables going on. Instead of just y and x, you have something like the z. So z equals kxy, where there's 3 variables being involved. And then combined variation means you're doing direct. So kx as well as inverse at the same time. So you'd be multiplying and dividing consistently. So let's evaluate some of these. Direct variation. If y varies directly with x, y equals 24, x equals 4, I can just plug those values in. And I'm going to solve for k, so divide by 4, we get k equals 6. So my representation would be y equals 6x. Y varies inversely with x. Y is 4, x is 8. So I'm going to get 4 equals k over 8. Multiply both sides by 8. We get k equals 32. Well, therefore, y equals 32 over x. Joint variation. The simple interest I for an investment is jointly proportional to the time t and the principal p. So we get I equals k t p because they're jointly proportional. So I'm multiplying all of them. After 1/4, 3 months, interest of 5,000 is 4375. Write an equation. So find that k basically. The interest is 4375 equals k time 1/4 or 3 months. I'm going to do 3 months, but you could do it in terms of quarters. You could also do it in terms of years. So you could put 1 right there. You could also put 1/4 right there. Either would be fine. And principal of 5,000. That's going to give me 15,000 k. I can divide by 15,000. So k has to equal 4375 divided by 15,000. So we get k is 0.0029. So we get I equals 0.029 TP. Okay. Find the interest after 3/4 or 9 months. Now, because I chose months in the first time slot, I have to be consistent. If you chose quarters there, you would use 3 in this case. So we would get 0.0029 times 9 months times 5,000. Now again, I'm going to use this value right here. So if you just plug this in, it'd be a little bit different because obviously we're rounding here. So we get 131.25. That would be the interest. Okay. Gas law states the volume of the enclosed gas varies inversely as the pressure and directly as the temperature. So we would get something like volume equals K over P because it's inversely the pressure, but it's directly with the temperature. So temperature is going to go up top. Then it gives me some values. Pressure is 0.75. Temperature is 24, and the volume is 8,000. So I get 8,000 equals K times 294 all over 0.75. I'm trying to get k by itself, so I can multiply both sides by 0.75 and divide by 294. So we get k equals 8,000 times 0.75 divided by 294. $20.41. So we get volume equals 20.41 T over P. Okay. Find the pressure when the temperature is 300 K and the volume is 7,000. So 7,000 equals 20.41 times 300 all over P. I want to get P by itself, so I can multiply both sides by P, and then I can divide by 7,000. So I know that P equals 20.41 times 300 divided by 7,000 times 300 divided by 7,000. We get P is about 0.87. And they had a label, which should be kilograms per centimeters squared. Thank you for listening, and I hope you have a great day.